everyone, and welcome to another show on teaching mathematics. Today we are joined by Robin again. Hello, Robin.
Hi, Helen. Great to be back.
It's good to have you. And then Dylan again behind the buttons. Thank you, Dylan. Okay, today we're discussing grade 11...
Reduction formulae.
Thank you. I wanted to say trig. I know it is trig,
it's a part of
but
trig.
Obviously it's not the whole of trig. It's actually just a very small part. But we may have some new people with us, so why don't you just quickly remind us who you are, very briefly. Who is Robin?
Well, my name is Robin Clark. I teach at WITS, and at the moment I'm lecturing teachers on how to be maths teachers. And it's a really exciting and interesting thing that I do. Love it.
I'm sure you do. I'm sure there are many people out there who are jealous. Yes. Okay, well, shall we get started by looking at the types of resources Mindset has?
Yes.
Well, so we are looking at the types of resources we have. We're going to look at a slide now that has the links that Mindset has. Basically, I found two, because this is such a small section, we only have two videos that focus specifically on it. And the one you'll see has a show note as well, which is very useful. If you're in a classroom, you want to find some questions quickly. And while Dylan opens that, there it is. We can see that it revises the content very quickly, and then it goes on to the questions. And of course, all of these questions are covered in the video that's linked to the show note.
And it's a great thing to hand out to learners to have a resource or to be able to have.
Yes, it is. Okay, shall we move on to the types of questions that we will cover in this section? Now, this is a slightly different format because when you showed me the types of questions, I thought this is a great way to lead into where we've come from, where we're going to, all of our usual topics. So we'll take a look now at the slide that has the 4 types of questions, and you've listed them.
Yes, well, when I was going through the show and looking at what I could teach you, then I try to identify 4 broad areas of questions that we would get within reduction formulae. And the first one is probably the most basic. It's just to write a trig ratio as a function of an acute angle. So if I can give an example, we'd have something like sine of 180 plus theta, and we want to write this out as a function of an acute angle, and obviously theta is an acute angle.
And obviously it's 180 degrees.
Yes.
Yes. Okay, and then the next one says simplify a trig ratio to a special angle and solve.
Yes, this is very similar to this, except it's when we have something like, and let me rub this out, it's when we get given a large angle, let's say sine of 210, and we don't really know what sine of 210 is. So we can simplify it into sine of 180 plus 30, and then by reducing it we can then solve it, get it into a special angle, and find the answer like that.
Okay, and obviously the degree signs over there as well.
Oh yes, I'm sorry. I have become a lazy teacher, unfortunately.
You know, I am I'm
but
reading
it's good
that
to be pedantic.
book, Teach Like a Champion, and they keep emphasizing that you must write down everything as you'd expect it. So now I've got my eyes out for that. I'm sure the viewers are feeling the same.
Oh yeah, absolutely.
Yes.
Absolutely. There's no excuse for not being accurate, and I'm sorry about that.
Number 3, trig ratios with large angles. Well, also very similar.
It's very similar, yes. Many learners want to just have small angles, and as soon as they see trig ratios with very large angles, they say, I can't do it. And while we're very good at adding, it's not as easy to break down.
Okay.
So it's very easy to say, okay, I can reduce, or I can simplify sine of 180 degrees plus theta. But it's not as easy to say sine of 750, for example. And so it's very important to get learners to understand that if you have a very big angle, you can easily whittle it away into an acute
Yes.
angle that you can work with. So that's point number 3 over there.
Okay, and point number 4, the use of reduction formulae within the trig functions.
Sorry, I think I made a mistake there.
Yes.
It meant within trig equations.
Trig equations.
Yes. So
I'm laughing because we had a similar mistake in last week's slides with Craig when we spoke about trig. Oh, it's
Okay.
coming back to me. Give me a moment. Carry
there
on.
you go. So the next section that
Yes.
teachers should be moving on to after reduction formulae is trig equations, where you actually are solving
Yes.
for theta or whatever. And in many cases, you get a very large angle, and you first use a reduction formula to get it down to an acute angle, and then you can solve your trig equation. So
Okay.
it's one of these things where you have 2 different areas of maths coming together to and it's good to be able to know that you need to use something from the previous section in the current section. So when you do trig equations, you need to be able to work with reduction formulae as well.
Okay. Yes, we did speak about this quite a bit with Craig,
Okay.
with the trig functions in grade 10 and how they don't yet link up to trig equations, but in how in grade 11 you can then bring them together with
yes,
this over
yes.
here.
Yeah.
This does link very nicely to the previous content.
Yes, the link that I've put up over there is an Everything Maths link, and it just links back to some of the grade 10 content, which is, I feel, a good basis to start building onto today's work. And it just shows how learners can work with the trig ratios within the cost diagram, and whether they're going to be positive or negative in the different quadrants.
So that content is quite important for this section.
Yes, it is. It provides a very good basis for the section.
Okay. Is there anything else that they need to know before they start this section?
No, they should just they should know the trig ratios, and they should know the cost diagram very well. They should know which ratios are positive or negative in the different quadrants, and that then helps with the content. And the other thing that I think is quite important is that I know grade 10s have just started doing trig graphs,
Yes.
and it's we'll watch a little animation later, but it's very good to be able to link up the unit circle with the cost diagram into the trig functions and the graphs, or the graphs of trig functions.
Yeah. Now, reduction formula, it's not really trig functions, is it?
No, but you can link it to trig functions, and many people don't ever see the link, but it isn't, but it's
Yes.
there is a link.
But
Yes.
it isn't, but it is. Yes. I'd like to talk about that more a little later.
Yes, we definitely should.
But why don't we go and look at the 5-point teaching strategy that you've lined out?
Sure. So for my 5-point teaching strategy, I've given 5 points, and the first one is that you really do have to make sure that you have the basics right. If you don't have the basics right of trig, then it's going to be very difficult. So the first thing is, do they know the trig ratios, and do they know how they work in the Cartesian plane?
So that's the revision, really.
Yes, that is the
Okay.
revision.
So first step for teaching this section is to revise those points that we've just gone
yes.
over.
And then the second step, or what I feel is the best way to introduce this, is to give learners the investigation, because if they have the basics, then they have the knowledge to do an investigation to discover how the reductions will work.
Okay. Define reductions for us quickly.
So reductions is what you basically want to do is you want to get a trig ratio of an acute angle.
Yes.
So, for example, if you have sine of 210 degrees, it's much easier to work out sine of 30 degrees, which is 180
So it's that
plus
whole
30.
concept of reducing the angle.
Yes.
The thing I found with teaching in the past is that often when you say reduction formulae to a class, they think you're going to present them with this magic formula that will work every time on every single ratio. Is there something like, I'm asking a stupid question because I obviously know the answer, but is there something like that in this case?
I hope I have the same answer that you're thinking of. There definitely are tables. There's a very big table that says sine of 180 plus theta is negative or positive sine. Sine of 180 minus theta is negative or positive sine. I mean, for the life of me, I hardly remember it. But the important thing is would you rather let your students memorize lists and lists of these reduction formulae, or would you rather give them the tools to work them out themselves very quickly, right there and then? Because I know that in an exam, my mind often goes blank with things that I've memorized. But if I have the tools to work something out, I'll be able to do it right there and then. Yes. And I think that's the point of reduction formulas, to get learners to know how they work instead of just learning a list of formulae.
I'd like to come back to this again because I like this conversation, but we'll talk about it when we talk more about the investigation step.
Yes.
Let's move on to step 3, which is talking about the table.
Yes, so step 3 is for learners themselves to discover and create a table of all the reduction formulae that have been investigated. But the point of creating a list is for them to discover and then record their results instead of just making a list that
so
that
it
they
wouldn't
memorize.
be copying a list, it would be developing it from the investigation.
Correct, yes.
And obviously through that they would be watching out for patterns
Yes.
within it.
Yeah. Or figuring out how it works, if there's any pattern or way that they can see why it works. My 4th point over there is explain how these can be used in a problem, and then that relates back to the different types of problems that we discussed earlier. There'll just be plain reductions.
Yes.
In reductions, you do get a little bit more complicated, where you might get a fraction with a whole lot of different ratios on the top and the bottom, and you expect it to cancel it and simplify it to the most simple form possible. And then, so
I want to talk about that quickly. Now, the fraction problems.
Yes.
Often what happens in class is that we teach them very well how to do a reduction formula or to use the reduction formulae.
Mm-hmm.
And then we give them a couple of questions which just say, sine of 210 degrees or whatever, but we don't quite take it to the next level.
Mm-hmm.
So they come to an exam and they've suddenly got one fraction multiplied by another fraction, and they've got all these reduction formulae.
And they don't know what to do.
No, because they're completely thrown.
Yeah. Well, I think it gets down to just being fluent in your procedure is one thing. Unfortunately or fortunately, whichever way you see it, this section it's quite abstract, and after you understand it, it becomes quite procedural. So you do need to practice quite a lot to get this right, and sometimes people say it's like geometry. You just have to see it, because there are cases where you'll end up with a sine and a cos, and the angles are different, and you don't really know what to do, and you just need for it to click that it's shifted by 90 degrees, so you can use your reduction formulae from 90, which switches sine to cos and cos to sine. This section does take quite a bit of practice.
Yes, I was just about to say that kind of thing does happen, but it has to happen after a certain amount of practice. And of course, the kids don't get it that someone, let's call him Bob, can just get it after 3 problems. He has got it waxed. He knows exactly what he's doing. But then poor Sarah, who's sitting over there,
just cannot see it.
No, has to do 500 problems before she even gets...
Unfortunately, this is a section where you just kind of do have to practice a lot. The aim for a teacher is to give learners the tools to be able to, you need a toolbox in your mind to be able to fix these problems up.
Yes. Yes. I'm looking forward to the rest of this discussion. I've got some things saved up. The last point says, explain how reduction formulae can be used in reverse, i.e. breaking up large or obscure angles.
So in many of the more basic questions with reduction formula, you just get asked to whittle away your angles, and it's already been given to you. Usually it's in the form of 180 plus theta, 360 plus or minus theta, and 90 plus or minus theta. In some problems it's 270 plus or minus theta, but it's usually split up for you in the beginning. and you just have to simplify it. Whereas in some questions, which get a little bit harder, you get given a very big angle, and you need to break it down yourself, and you need to identify, is it 180 plus something? Is it 360 minus something? You need to figure out which quadrant it's in. If it's over 360, how many times do you minus 360 until you have something to work with that's within 360, and then whittle it away again? So it's, if you look at your sine graph, we repeat every 360 degrees. So it's...
And I suppose bringing that in now will lead it nicely into the trig equations, as we've spoken about before. Now, you mentioned something there, the 270 plus. As far as I know, and I stand to be corrected if anyone out there can correct me, I don't think the CAPS document requires us to do 270.
CAPS doesn't require us to do 270 anymore, but I still find it nice to do.
Yes.
Just so that learners get that extra practice and understanding of how reduction formulae work. So it's not required, and usually if something is in the fourth quadrant, then it's 360 degrees minus.
And then you would do the 90 minus.
Yes.
Rather than, technically if you reduce like that, the 360 minus theta, you would change to its cofunction by doing 90 minus.
90. Yes.
Not 90 plus.
Yes.
Yes, because you've taken it to its acute angle.
Yeah.
Yes.
90 minus.
So I often wonder why, if they've taken out the 270, why did they bother to leave a 90 plus? Because you're teaching them to reduce it to its acute angle.
Yes.
Why?
Yeah. I think the cases that use 90 plus or minus are when you are working with a fraction and you cancel, and or you simplify and you cancel, and there's a sine and a cos left, and if they add up to 90 degrees, then you know that you can switch it by 90 and get two similar things.
No, I do understand. but what I'm thinking is 90 minus, yes, we'll use it a lot.
Yes.
But 90 plus, if you're teaching them first reduce to an acute angle, then why do they need to know 90 plus?
Yeah.
It just, if you're teaching them 270 plus minus, then sure, they need to know. I'm not expecting you to have an answer here, but
I think we'll have to figure that one out.
It is something I've wondered about. Why bother?
Sure.
Yeah. Okay, now let's go into the 3 pressure points. Okay. So be aware of letting learners learn the reduction formulae by heart instead of teaching learners how they work. Explain that, please.
So I'm very aware that when it comes to exams, learners, their mind just becomes like a sieve. They've done so much studying, and you can't expect a learner to memorize absolutely everything. And as far as I know, reduction formulae aren't given on the formula sheet in an exam.
I don't think so, no.
Nope. So I would far rather a learner knows how something works and has the tools to figure it out in the exam than to have rattled off a list of reduction formulae by heart and then get into the exam, suddenly forget it, and then they're stuck. Because if they've only learned a reduction formula off by heart, and they forget it, that's that for you. It's not going to be very easy.
Yeah.
But if you know how to work something out, then you have the tools to do that in the exam.
I suppose at the end of the day, this time they spend memorizing a table of reduction formulae, they could have been spending on applying the understanding.
Correct.
And yes, they're not going to be able to recall, like parrots, what they are, but they'll have the tools, like you said.
Obviously, if you have the tools to work it out and then just memorize a couple to make things faster for you, as long as you don't forget them, it does make it quicker for you. But if you do forget them and you still know how to work them out, it's not a problem. I just want to make sure that you don't only learn it off by heart and not know how to do it.
Yes. I want to go back quickly.
Yes.
While I'm still thinking of it. You said something a little earlier about this being something they do from understanding and then they move to routine.
Yes.
Yes. But in trig functions, we were talking last week, and it was talking mostly about drawing, knowing how the shape goes. But we were talking about plotting the functions
Mm-hmm.
and learning how to navigate the Cartesian plane.
Yes.
But then seeing the shape of it,
Mm-hmm.
and then learning the shape and learning the characteristics of period and things like that. And I've possibly used the wrong example, because there are other things that you first learn procedurally and then you develop the understanding afterwards, whereas this seems to be understanding and then procedure. Is that a correct
I would...
observation?
Yes and no. I think yes, it is very important to get a good understanding of this before you start. When I said procedure, I don't know if I meant just when you have graphs, you plot a point, and join them. That is a very procedural way of thinking. When I said procedure, I think I meant more of it. You have to have fluency in your procedure, because yes, it does become a procedure as long as you understand it, but it's almost at a higher level.
Yes.
If that makes sense to you, in that being able to click and just see it. That's how it works. It takes a lot of practice, but that practice is based on a deep understanding of reduction formulae to start off with.
Okay.
Have I answered your question?
I think so.
Okay.
Yes.
Mm.
Okay, back to the pressure points. I'm
Yes.
sorry, going off on a tangent. Second one, teachers should teach by letting learners do investigations. While doing examples is good, it should not be the only method of teaching.
Yes, I found that when I go visit classrooms, teachers say, these are the reduction formulae, here's 4 examples, and that's the end of their lesson. And I find that to be a very, while it does work in some cases, and I don't think it's necessarily bad, I don't think it should be your only method of teaching, because learners get bored, or you really could be giving them a better understanding. So I think that in this topic especially, doing an investigation is really helpful to the learner, because if they know the grade 10 content very well, they'll have the tools to discover reduction formulae, and basically what you're looking for in reduction formulae is the sign. Is it positive or negative within the quadrant within
Yes.
where it falls? And grade 10s do know that.
Yes.
So this is building on it. And I think that if a teacher gives a grade 11 a well thought out investigation, learners can discover these reduction formulae for themselves. They might need a bit of help, they might need a bit of scaffolding, they might need a pointer here and there. But if you purely just stand up and say, this is what they are, this is an example, finished,
Yes.
then it's...
It doesn't make any sense.
Yeah.
It doesn't bring anything together. I'm very cautious of the approach of just putting examples on the board and saying,
Sure,
learn.
I don't think examples is bad, and I definitely do think you do need some examples to show learners the right way to go, but it can be combined with different methods of teaching.
If you're just giving examples on the board, you're just drawing the CAST diagram and you're putting positive, negative, CAST, whatever.
And that's that.
Have you really taught them anything?
Maybe, but not enough.
The third pressure point. It is very easy to see reduction formulae as a separate topic. It's very important to be able to link the CAST diagram with the graph of the trig function.
Yes.
Yes. And it all comes together, doesn't it?
Yes, it does. It does. And I'm not too sure if we have our animation ready yet, or if we're going to get to that, but there's a very nice animation that shows how the CAST diagram links with the trig function.
Dylan has pulled it up for us.
So, Dylan, can you press play?
Yes. So it forms the triangle, and we actually looked at this last week with Craig, how it forms the triangle going around the unit circle, and you see the length
and this
translating into the sine graph.
Yes, and this is obviously sine, so as soon as it crosses into the third and the fourth quadrant, it goes under the horizontal axis and becomes negative, and there we have it. So that's
actually a beautiful way to link it up. Maybe would you show that after the investigation, after they've...
Yes, I think I would, and I'm actually going to just sort of replicate that. And what many people don't realize is that, and this is a very rough sketch, if we have sine of theta, and if theta is an acute angle, there'll be an answer somewhere over here. And if we look at our cast diagram, there are 4 places where we will have exactly the same answer, and they differ only in their sign. So these answers will be negative, these answers over here will be positive, but there are 4 places. So this obviously over here is sine of theta, this over here is sine of 180 plus theta.
Minus.
Sorry, all right, getting ahead of myself. So we are at 180 degrees and we're going backwards, theta, and this over here will be sine of 180 plus theta, thank you very much, and this over here is sine of negative theta, or sine of 360 minus theta. So there will be 4 places, and obviously over here in our cast diagram, I didn't even write it right. There we go.
I was wondering, but being upside down, I'm sorry. I thought it was me. Carry on.
You know, when you talk and you write at the same time, not everything comes out right. So as you see over here, sine is positive in these 2 quadrants and negative in these 2 quadrants. That's why our answers in quadrant 1 and 2 are negative, and our answers in quadrant 3 and 4, 1 and 2 are positive, and quadrant 3 and 4 are negative.
Okay. That is a really nice way to link on to general solution later.
Yes, it is. Because what we know is in general solution, our graph just keeps on carrying on and on and on, and our answers will repeat on and on and on and so on. And I think I've gone off the camera there. But it carries, the nice thing about sine graphs is it carries on forever, and that's why with general solutions we can either have a general solution or a specific solution where you have answers between a certain set of points or answers that carry on forever, which is why we have plus 360 times k.
Yes.
And so on.
Yes. But of course that's not today's topic.
No.
Now, you have prepared to talk to us about this investigation that we keep talking about now in our section, Let's Get Practical.
So can we bring up...
Now, the link to the investigation is up on screen. This investigation can be found in
the Siavula website in grade 11, and it's actually on the page that deals with reduction formulae, and it starts... and if you just scroll up a little bit, it says deriving the reduction formulae, and it gives an activity for the learners to do, and I think it's a very good activity for learners themselves to just start off with finding out what reduction formulae are about.
And I see that it's used a radius of 2, which of course links to the special angles.
Special angles, yes.
Yeah.
Yes, and what learners shouldn't forget, and sometimes they do, is that the radius is always positive because it's a length, whereas our x and y values can either be negative or positive depending on where they are in the Cartesian plane.
Yes, I remember when I was teaching length to maths lit class for my sons, I'd walked backwards and asked them if I'd walked a negative distance, and Thankfully, they said no, but it is a good thing to illustrate that distance is only ever a positive measurement.
Yes. And so if you scroll down, you'll see that it looks at 180 minus theta, it looks at 180 plus theta, and then it carries on and asks learners to then find out. And then the rest of the page gives examples. It's more of a textbook, but that first part just gets learners to investigate the sign of a trig ratio depending on where it is in the Cartesian plane.
Okay, let's talk about this practically. Now, the investigation was point 2 of your teaching strategy, and it was this particular investigation.
Yes.
So point 1 is you've now revised cast diagram from grade 10 knowledge, and have you revised trig functions to get to that point, or?
I think it would be very beneficial. It's not necessary, but it is good to find a link that so that everything falls into place.
Okay. How much time would you spend on that revision?
I think not more than 2 or 3 lessons, because obviously the curriculum is tightly packed as it is.
And we've also just come from trig functions in grade 11.
Yes. Well, then no revision is necessary if you've just done that. Yes.
So then we're just revising the cast diagram, 5 minutes?
Yeah, I would say half a lesson.
Half a lesson. Okay.
I don't know. It depends on how forgiving you are with your class. Some kids, as soon as they leave grade 10, seem to press the button and absolutely everything disappears, and some don't. So it depends on how much your learners remember. If they remember a fair amount, 5 minutes should do it. If they don't remember anything, a lesson should do it.
Okay, with the revising the cast diagram, are you just revising what's positive where?
Yes. So what I would do is I would draw a cast diagram, a Cartesian plane, and then get learners to say, well, sine of theta bigger. Sine of theta is the opposite over the hypotenuse.
So I'm going to stop you here.
Sorry, do you prefer that I work in X, Y, and R?
Well, I think the CAPS document, but that's not why I'm stopping you here, because I would always write, when I was teaching, I would always write opposite over hypotenuse and then equals Y over R, just so that they have the comparison. But that was my personal teaching technique.
Sure.
What I'm wondering is, with your investigation, aren't they doing this kind of calculation or this kind of revision within that investigation?
Yes, they are, but it does get a little bit more complicated. But I suppose, yes, they are. They are doing that sort of thing. So it might be, if you design a very good investigation, it might have elements of revision in it, and then you don't need to do revision. But what I would do is just, maybe you're right, 5 minutes is more than enough. Y over R. Y is positive in the first quadrant. R is always positive, therefore sine of theta in the first quadrant is positive. And carry on, go around, do it with sine, cos, and tan, and then we'll see that in the all are positive in the first quadrant, sine only in the second quadrant, tan only in the third quadrant, and cos only in the fourth quadrant.
Funny enough, the main misconception I found with the cast diagram, teaching it to grade 10s, was that they would see all, and then they would see the sine there, and they would immediately assume that only sine could fall into that quadrant, that cos and tan would never have an angle of between 90 and 180 degrees.
What I would do in grade 10 is I would do a more complicated cast diagram, and I would go sine, cos, tan, sine, cos, tan, sine, cos, tan, sine, cos, tan, positive, 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 negative, 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 positive, positive, negative, negative. There we go. And so that learners would understand that each of the ratios could fall in every quadrant. But you have to understand where they're positive and where they're negative, and that's the important thing.
I think this kind of revision is really good for the grade 11 start, not just, and then after that, say, okay, well, all of these are positive.
Yeah.
And we
C.
say this is, yes, exactly.
There
And
we go.
that's where we get the cast
Yeah.
diagram from.
Yes.
Yes, I would also make them then fill out the 0 degrees over there, and this is 180 degrees over there, and I am writing upside down.
There we go.
And then that would be my basic revision.
Yes.
Am I doing too little?
No, I don't think so. I think that's good. Anyone can say this is a cast diagram, but going into where they're positive and where they're negative and why really is important, because why is tan negative in this quadrant? And over here, our if we look at it, our x value is negative,
Yes.
and our y value is positive.
And our R
And
value is always positive,
Our r value is always positive.
but of course that doesn't affect tan.
Yeah. But tan of theta is y over x, if I'm not mistaken.
Yes.
And when we have a positive divided by a negative, we will get a negative answer, and that's why tan is negative in that quadrant.
I'm just thinking here, with that diagram, with the unit circle and the sine graph, and obviously they have those kinds of diagrams for the tan graph and all of those things. If we did that the week before within the trig functions, it could actually link very nicely to this revision. You could almost do that revision while you're doing functions and revise where functions are positive and negative and
Yes.
according to the quadrants. And
Yeah.
then you don't need to do revision over here.
And if we look at the tan graph, over here tan is positive.
Yes.
In the second, it is negative. In the third, I didn't put a dotted line there, it becomes positive again, and in the fourth, it is negative. So it's wonderful how we can always link up our graphs to our cast diagrams.
I think this will flow really, really nicely,
Yes,
actually.
I think so too.
If we teach
Mm.
the functions from this point, well, just mention this
Yes.
in the functions section, then we can flow it nicely into the cast diagram, which then flows well into the reduction formulae. Okay,
Absolutely.
let's move on to the investigation. So we've done a 5-minute review,
Yes.
and do these beautiful learners then do the investigation by themselves or in groups?
I think they I was going to say by themselves as in not with a teacher, yes. By
Yes.
themselves as in individually, no. I think that there always is, good work is usually done in groups as long as it's not in huge groups. So I would limit my group to 2 or maximum of 3 learners,
Okay.
and then do it together.
And what
Yes.
kind of outputs are you expecting from them? What kind of conclusions must they draw from this investigation?
Well, I would like learners to say something like, okay, well, sine of, let me think, sine of, give me a good one, sine of 10 and sine of 170.
Yes.
These two should be the same.
Yes.
I'm going to call you the degree lady. You obviously have lots of degrees.
Oh, I wish. Yes, so these two, according
I've
to
used
the
up all
trig
my
functions that we
Yes.
have just revised, and
These
These
two should
two?
be the same.
yes.
And within my investigation, if learners don't know that they're the same, discovering that they are the same should be exciting.
Yes.
And they should find, wow! Because if you put sine of 10 degrees into a calculator and sine of 170 degrees on the calculator, you're going to get...
The same answer.
Yeah, 0.8
Yes.
something or 0.9 something. Round about there. I don't have a calculator with me.
I'm impressed.
Oh, no, it's going to be that. It's going to be very small, not very big.
Yeah.
Never mind.
Okay.
Think of
So
sine
they
of
get the
80.
same answer,
Yes.
and then they go, but why?
Yes.
Yes.
And that is then an introduction to look at 10 degrees and 170 degrees and how they're the same there. And on my sine graph, it'll be there and there.
So in your investigation, you're looking at them represented as angles. You're looking
Yes.
at it represented on the Cartesian plane. And
And
then
then-
you're looking at it as a graph.
Not necessarily to start off with, but that's what I would like learners learners to aim for is linking all of these.
Why
How are these
can't
all
they
made the same?
be linked from the beginning?
They can be linked right from the beginning. I just don't think that learners will, unless they're scaffolded or prompted, they themselves won't link it right from the beginning, but they'll get there. They might need a little hint or a push.
I wonder if there's a way to phrase questions to get them to link it together from the beginning, and then from that introduce the general, have that like investigation part 1 and investigation part 2 is in 2 weeks later, 1 week later, whenever general solution is, and it links directly to these kinds of problems.
Yes. I think this is when the animation of the unit circle going into the graph, that will help them.
Yes.
So, like I said, learners just need a bit of push or a bit of scaffolding. The animation will definitely help to make this connection.
Okay. So they have now done this, and they have come to the conclusion that 10 degrees, sine of 10 degrees, has the same answer as sine of 180 degrees.
170.
Thank you. Okay. What conclusions? Do you then draw conclusions as a class about this, or do you get them to write their own conclusions down?
Well, usually the conclusions, there'll be a list at the end of the investigation that says sine of theta is equal to sine of 180 minus theta is equal to sine of 180 degrees plus theta is equal to. And then in this part over here, you'd want them to say it's positive, it's negative,
And
then it'll say positive what? Sine of theta. Obviously, sine of theta is sine of theta.
Yes.
This will be positive sine of theta. This one will also be sine of theta because they're the same, except at this point it's the same value, except it is negative sine of theta. I'm going to rub those out because that's confusing.
Yes. I do think this is a valuable exercise. But I am also thinking there are 4 quadrants and there are 3 ratios. That's 12 different investigations they've got to do. And are they really investigating it properly if they're only doing 1 ratio or 1 acute angle in each one?
Well, I think that the learners are very capable of seeing patterns. So as soon as they understand, wow, depending on the sign in the quadrant, that's how I'm going to reduce it.
Okay.
I'm going to reduce it, and so once we've drawn a conclusion that, like I could say here, once I've drawn a conclusion that sine of 10 is equal to sine of 170, I can say, okay, sine of theta is equal to sine of 180 minus theta.
Okay.
And knowing that in the 3rd quadrant, sine is positive. You see,
Second quadrant.
sorry, in the 2nd quadrant, sine is positive. I know that this will be positive, and I will have sine of theta being equal to sine of theta.
Okay.
Sorry, I should make that positive.
Now, my thought is maybe the class should be divided into 3. We have some that are investigating
The
tan,
sine and the cos and the tan.
and then comparing results somehow.
That's also an amazing strategy, and it's an
Thank you.
investigate and teach strategy. So all the learners who are stuck with sine will be teaching the others about sine. The learners who get cos will then be able to share their results, and the learners with tan are then also able to share their results. Otherwise, you might want to separate it up, not into sine, cos, and tan, but into quadrants. Although people who get the first quadrant won't really get much work.
No, they'll be very bored. But that
Yes.
is an interesting thought. However, then they're not comparing the ratio in different quadrants. And are you
Yes.
really getting understanding?
I think you are, because different ratios are different
world.
signs in different quadrants. I'm
Yes.
getting very confused about talking about a sine as in
yes.
and a sine.
Maybe we should be talking about cos rather, or tan.
Exactly.
Yeah.
These are the occupational hazards of being a teacher.
Yeah. Okay, I must admit, when I was teaching this section, I used to say to my classes, listen, as soon as you get your exam paper, while no one's looking, just quickly draw the cast diagrams and write into each block where it's 180 degrees minus, 100 plus, and then I'd also get them to fill in the 90 minus and the 90 plus.
Yes.
We haven't discussed where that comes in. Do you introduce the co-functions? They're called co-functions.
Co-functions, yes.
Yes. In that same investigation, or do you do it at a separate point later?
I think I would do it later. I would really like my learners to really understand looking at reductions from 180 degrees and 360 degrees, and then after that go into reductions from 90 degrees.
Yes.
And the wonderful thing about reductions from 90 degrees is once again the graph, because if we have a look here at our graph, this is our sine graph. I'm going to try to draw this neatly. And cos is starts from 1, am I right?
Yes, you are.
So let me just...
Okay, so we'll use our imagination a little, that it does...
slightly skew.
Yes.
But as you can see, that the sine and the cos graphs are absolutely exactly the same. The only thing that they differ by is 90 degrees. It's been shifted by 90 degrees. That's why when we have 90 degrees plus or minus theta, our graph shifts from being a sine graph to a cos graph, because they are 90 degrees different. And we just need to make sure that, I mean, in some places, while sine is positive here, cos is negative here. So that's why we just have to look and make sure about sign, S-I-G-N. Yes.
Yes. And the swapping of the sign. Or not swapping, but the...
Yeah. Getting the correct sign.
Yeah. It's almost like you need a whole nother billboard up above your head when you're teaching co-functions versus reducing an angle, so that they don't get the two confused, because it is confusing.
Yes,
you're using the same cast diagram, and
you are.
Yeah. Oh. So, perils of being a maths teacher.
Absolutely.
Okay, well, we are actually surprisingly running out of time, so I'd like to switch over to one last thing, if we can. Thank you, Dylan. Okay, I am quite excited about this one. As everyone knows, I've been reading this book called Teach Like a Champion.
Also one of my favorite books.
Well, actually, you were the one who recommended it to me, so thank you very much. And I've been going from the beginning to the end and just picking out every actionable step that he has in there. And today's actionable step is without apology, which is quite abstract, and it's basically says don't apologize for the content or for the students. So there are two parts to it, and when he says don't apologize for the content, he's basically saying don't stand up, and especially in a section like this, say, listen, this is in the syllabus, we just have to do it. You are going to find it difficult. I'm really sorry about that, but let's try it and let's see how it goes. By doing that, what are you doing?
You're making excuses for the beauty of maths, because
yes.
I find that this is really beautiful. It just shows the pure beauty of mathematics. But if you say, I also don't like doing it, and I'm really sorry we have to do it together, it's not very inspiring to students.
Yes, I remember listening to a history teacher the other day. Okay, it was quite a while ago if I'm remembering it, but sitting there and talking about this one section that they had to teach, and they're going, oh, but this section is so boring. And I thought, how can history be boring? How can you make a story boring? And well, I'm pretty sure the class found it boring because they just didn't do anything about making it interesting.
Absolutely.
Okay, I did find a quote in the book that I really, really enjoyed, so I put it onto the next slide. And he's talking about his college years and this one class that he got on his timetable, and he meant to change, but because he was a lackadaisical student, he never got around to swapping out the class, and it was on English literature or something, and he really wasn't looking forward to it. But then he says about his teacher, Professor O'Neill somehow convinced me that the well-being of the world urgently required me to stay up late reading William Wordsworth. Now, I've never read William Wordsworth, mostly because I've heard it's boring. And yet, here's a professor who is taking a student who's not interested in the subject at all and making him stay up late because of his passion for the beauty of his subject. Like you said, the beauty of mathematics.
Sure, yeah.
Now, the other thing that he talks about is no apologies for students. And don't we all do that? We say,
absolutely do.
Yeah, you know, it's my 10F class. You can't expect much from my 10Fs, can you?
Or that child just got pushed through, so I know they're not going to do well, so I'm just not going to put that much effort into it.
Yes, or shame. It is hard for them with this and that. And by setting up the low expectations, do you give the child any chance to excel?
Yes. I don't think we can ignore the fact that many children in our schools do have problems.
Yes.
But there is one thing that will help them get past their problems, and that's education. So we need to look at the long-term goals as well. And that is giving a child a good education. And giving them a good education means not having any apologies.
And I don't think it's ignoring the problems that they have at home.
No, it isn't. It's just looking at a different
not using them as an excuse.
Looking at a different aspect of their life.
Yes. Oh, I like this topic. And you know what I love about mathematics is that, especially with teaching teenagers, is that every day they come into class and they sit down and they know what they've got to do and they get it done and they leave. And if they get it wrong, they get it wrong. It's not this huge, how is this emotional thing going to affect me? And I know some of them come in with these emotional issues linked to mathematics, but get them over it, because it's a chance to just do something systematically and be rewarded for doing it systematically. It's the one thing that will be constant.
Yes.
Especially with all their hormones.
Yeah. And if you make your classroom a safe but enjoyable place, it'll be a place where they find comfort at the end of the day. Comfort in routine and knowing that they'll have fun.
In the calculations, in the discovering the difference or the similarities with the cost diagram. And it's such a beautiful subject, and it's such a privilege teaching it to teenagers. It really is.
Yeah.
Okay. Well, thank you for joining me on that emotional note.
Well, thank you, Helen. You've made me miss teaching terribly.
Yeah. Anyone needs some maths teachers for a day, you know where to find us.
Yep.
Otherwise, it's been wonderful having all of you join us. Thank you to Dylan for the behind-the-scenes magic. And we'll see you again next week for Grade 12 Analytical Geometry. Thank you and goodbye.